In the previous video, I have discussed what is normalization and what is need of normalization, right? So now in this video, we'll discuss about first normal form, because normalization is having multiple levels, or you can say multiple normal forms are there, right? So the very first or basic normal form is that is first normal form. Now we will see how you can say that a particular relation, the particular table given is in first normal form or not, and if not, then how to convert that relation into first normal form, right? And also we will discuss some important points about first normal form. So if you have worked on any project, definitely if you are in BTech third year or final year students, then definitely you are working on some projects. Then in your project you have ER diagram, right? I am taking a small example of ER diagram. Here I have only two entities, student and course, one relationship between these entities, and these are what? Attributes. Fine. So now here my motto is just to show you what is composite attribute. This is composite attribute. It is made up of all means it is made up of another attributes. Address is containing house number, state, city, country, like this, right? And phone number is what? Multi-valued attribute. Multi-valued attribute means an attribute that can have more than one value, means a student can have more than one phone number, 2, 3, 5, something like this, right? So now see, this is just a simple or small ER diagram I want to show you. Fine. Now once you when you convert this ER diagram into tables or into relations, obviously you have to convert, you have to make a database, you have to design your database, right? So you have to make some tables, you have to convert this ER diagram into relational tables, relational schema. How to convert ER diagram into relational schema, that also we will discuss in a separate video. Fine. So in that case, in the table, each entity is you will consider as a table. Table name is student, and in that table attributes would be all the attributes of this entity, right? Now ER diagram is having composite attribute as well as multi-valued attribute. Fine. It means when you create a table something like this. Now suppose I have converted this, I have just taken only one entity, that is student, and I have make only one table, not I am going to complete the going to convert the complete ER diagram, right? So now here suppose I have written something like this. Student ID is primary key, so this is student ID, right? Student name, student address. In address I am taking, suppose not taking all the attributes here, that is house number, state, city. I am writing only state and country, Haryana, India. This is also Punjab, you can say India, Rajasthan, India, and Haryana, India. And phone number are, suppose this one, Jenny is having two phone numbers. This is having, GI is having only one, Pile is having two, and Shanvi is having only one phone number, right? So this is what? Multi-valued attribute, and this is what? Composite attributes. But this relation, this relational schema is not in first normal form. You cannot convert it something like this. You cannot, when you convert an ER diagram into relational schema, then relational schema must not contain any multi-valued attribute, right? And composite attribute as well. Now if, obviously we will write address and phone number here, but you have to convert it into now first normal form. Why this schema is not in first normal form? Because the condition or the rule is what? A relation is in first normal form if and only if all the attributes are having atomic domains, or in another word you can say each column or each attribute, obviously this is what? Attribute, or you can say column, each column should contain atomic values. Now what does this atomic means? Atomic means that cannot be further decomposed into smaller pieces by the DBMS, right? Or you can say individual unit, that is what? Atomic. Now each cell, or you can say each column, but this column, see, what about this P1 and P2? This is containing two values, it is not atomic, right? If this is what atomic, it contains only one value, that is P3, only one phone number, right? Obviously there would be some phone number. This is also containing two, so this is not atomic. This is also containing two values, so this is not atomic. So that is why this table is not in first normal form. If you want to convert it into first normal form, then you have to make each cell atomic, means each cell or each column should contain atomic values, right? That is the first rule and the very important, or you can say the main rule of first normal form. So this is the first point, that each attribute means, or you can say the rules. Here you can write a relation is in first normal form if it follows the following rules. And the first rule is each attribute should contain atomic values, or here in another word you can write each cell contains exactly one value in simple terms. Now how to convert it into first normal form? See, suppose here I am taking only 3 student information, not 4 student information. So now how to convert it into first normal form? See, if composite attribute is there, then what you will do? You will make separate attributes or separate column for each of the attribute. So here is what? In this composite attribute, this is made up of 2 attributes I am taking. One is what? State, one is what? Country. So 2 separate column you will make, one is for state, one is for country, and there you will write state, and in one you will write India, or you can say the country, right? What about multi-valued attribute? If multi-valued attribute is there, in this multi-valued set we are having 2 entries, right? So you will make separate, or you can say one tuple for each value in the multi-valued set. In the set I have 2 entries, so you have to make 2 tuples, one for P1, one for P2. So in first tuple I am taking this one Jenny, the address, and P1. In another tuple again, obviously SID would be same, name would be same, Jenny, address would be same, but only change is what? This one. Here we have P2. This is how we are going to convert it into first normal form. Now you can say this table is now in first normal form, right? Obviously we are having some another rules also. Here we have discussed only one rule, right? I am also going to discuss all the rules. See, now you can say each cell is having only one value, you can say, you can see here, right? Or you can say each attribute is containing only atomic values here, right? See, I am not saying that this is the only way to convert it into first normal form. There are only mainly 3 ways, that also we will discuss, right? Now second point is what? Second rule is what? First rule is this one. Now second rule is a column should contain values from same domain, or you can say in simple terms you can say a column should contain values that are of same type. Now what does that mean? SID, here I am taking, this domain is what I am taking integers, right? So here we cannot store, we cannot here add S name, like I am here I am writing Shanvi, and here I am writing the roll number 4. That is wrong. If you are, this domain is what? Integer, you are storing here the SIDs, then you will store SIDs only in every row. Here you will store only S names, you cannot store roll numbers, right? So every column, the domain is what? Whatever the applicable domain on that column, all the values in that column should be from that domain only, right? Here we cannot store integers value. Here obviously this is what? Integer, phone number would be in integer form, so here we cannot store string values, right? Because we have defined already the domain of each attribute, right? This is the second point. Now third rule is what? Each column should have unique name. It's not like that here also I am taking phone number and here also I am taking phone number. 2 columns are having same name. That is not correct. If this is the case, then that table is not in first normal form, right? Because obviously that would be incorrect. We will not able to find out which phone number we are asking. If someone is asking, then which phone number he is asking, right? This phone number or this phone number, right? If suppose I am taking S name, that is also not possible, right? So each column should have a unique name. That is third rule. Fine. Fourth rule is what? No ordering to the rows and columns are applicable. See, it's not like that this row you will be first, this row would be second. No, maybe you can write 1 Jenny HR, this information here. After that you can write this information 3 Payal Rajasthan India and P5, right? So no top to down ordering to the rows and no left to right ordering to the columns. Maybe you can write this attribute here, SID after that. Maybe you can write SID after phone number. Maybe you can write country here, state here, So the ordering does not matter. This is the fourth rule. Fifth rule is no duplicate rows would be there. Obviously, it's not like that. Here also I am storing 1, Jenny, HR, India and P1. This row and this row would be exactly same. So that cannot be a case here. And if obviously if we are taking 1 as a primary key, then this is not allowed. And every relation or every table must have a primary key, and if obviously this relation is having a primary key, then this condition, it will not be a case here, will not occur, right? So now if every relation must have a primary key, obviously when you are designing a database, then every relation must have, every table must have a primary key. So which is the primary key in this relation? SID cannot be a primary key because values are repeating here. SName also, state also, country also. But here in this case, suppose I am taking only these entries, so phone number you can consider as primary key. But sometimes it happens that आपके पास एक बहुत maybe पुरानी सिम थी जो आप use नहीं करते, and now that number has been assigned to another person, right? So maybe here also in the database I have here P1 and P1 same phone number. In that case, what can be the primary key in this relation? It is not compulsory that primary key will contain only single attribute. We have already discussed all the type of keys in detail, right? You can check out that video in the I button. So now here we can consider what? Both SID and phone number as a primary key, right? Because as you can see, if you combine both SID and phone number, that will definitely uniquely identify each record in this tuple. I'm not going to going into the detail of primary key because we have already discussed in detail. So now this would be primary key in this relation, no problem. It is not compulsory that only SID must be a primary key. So now these are mainly 4 rules. A relation is in first normal form if it will follow these rules, right? Otherwise it is not in first normal form. Now the very important point is what? This is what a theoretical concept, first normal form. When ER diagram is converted into relational schema, then definitely that schema would be in first normal form by default, right? Definitely when you are converting ER diagram into relational schema, then every multi-valued attribute would contain a separate table. It's not like that we will combine into the same table, right? Composite attribute would be denoted like this with separate columns, right? So by default that would be in first normal form. Now it's your responsibility to convert into second, third or BCNF, whatever you want, right? If this relational schema is not in first normal form, then definitely your ER diagram is not good, or you can say your database design is not good. So you can say a good ER design means good relational schema you will get, right? If bad ER diagram is there, then definitely you will get a bad database design. Fine. And if this generated relational schema is not in the desired normal form, then you can correct it. You can fix that problem into this ER diagram only. You can fix it, and after that again you can convert and you will get the desired normal form in this relational schema. Or if you not fix the problem into this ER diagram, suppose this relational schema in second normal form and I want that it should be in BCNF. Then after converting into the relational schema, I can apply somehow we will convert this thing from first normal form to second, third or BCNF like this. That also we will discuss in detail. So here also you can convert, or you can convert it into, you can fix this problem into your ER diagram also, and after that you can convert it into relational schema, and after that you will get that your relational schema is in BCNF, right? So now here you can say first normal form is essential property of a relation in your relational schema, right? Definitely your relational schema, if in a question it is given that consider this relational schema, then definitely that is in first normal form. They will never ask you in exam that whether the given relation is in first normal form or not. Definitely it will be in first NF, right? So it is a theoretical concept. Now different ways to convert. First way is this one. This is how we can convert that table into first normal form. Second thing is what? You can divide the given table into 2 tables. I have told you that for each multi-valued attribute there would be a separate table. Now what is that second way? See, so this is the second way. You can divide the table into two tables, or you can say for each multi-valued attribute you will create a separate table. So here I am taking that multi-valued attribute, that is phone number, and obviously with phone number I am taking this one, primary key. This is what primary key here in this table, right? And here this will act as a foreign key, right? And for this table primary key would be what? Both SID and phone number. If the situation is I am taking that this also P1 and this also P1, obviously maybe we haven't updated the old phone number of Jenny, and that phone number has been assigned to another person now, so that is also having P1, so we cannot take phone number as a primary key, right? So now both would be primary key here, and this would act as a foreign key, so this would refer to this SID. This is our base table now, right? So this is now, you can say this is now in first normal form. These tables are in first normal form. All the conditions are satisfied. Each cell is having only one value. Each cell is having value in that particular domain, right? And here also I am taking what? No duplicate rows are there. Ordering of rows here also does not matter, and each column is having unique name. So these are in first normal form, right? This is the second way to convert a table into first normal form, right? See, here in this case one to many relationship are there. One SID is 1, and this is in relationship with two phone numbers, means one to many, P1 and P2. From here 1, here I can get two rows, 1 and 1. Here 3, here I can get two rows, that is 3 and 3, that is P4 and P5. So now we know 3 pile is having two phone number, that is P4 and P5, right? Because we have established a relation between these using foreign key, that is SID, right? And this SID is primary key in this relation. And third way is what? You can take, here we have that multi-valued attribute, that is phone number. So in the same table you can do what? Phone number 1 and phone number 2, like this. So this is the third way. Here what you have done, this multi-valued attribute we have divided into two columns, that is phone number 1 and phone number 2. So here I can write P1, P2. This is having only P3, one phone number, so this would be null. Here not 0, it is null, and this is also having two phone number, that is P4 and P5. But this is not a good way to convert it into first normal form, because almost this phone number is having, the columns are having same name, right? We can't distinguish, like in phone number 1 we will write P1, and in this phone number 2 we will write P2. Maybe here also I can write P2, here I can write P1. So that would be ambiguous situation. And here the problem, again one more problem is what? Suppose phone number is having, one student is having 10 phone numbers. So 10 columns you have to make definitely, right? And remaining students are having only 1 or 2 phone numbers, right? So for remaining students, for those phone numbers columns you will have to fill what? Null, null, null. Many nulls would be there in your table. So that is also a problematic situation, right? So this is not a good idea to convert it like this. So here the best idea is just make a separate table for multi-valued attribute, right? For composite attributes, make separate columns. Fine. This is the best idea to convert a relation into first normal form, right? Now see, maybe you have a question in your mind that if here I'm saying that all the columns should have atomic values, right? That cannot be decomposed further. So now SIDs I am taking suppose 1, 2, 3. So now you will say that we can decompose it like 1, 2 and 3 into 3 parts. So that is also what? Non-atomic. But the rule is what? Set this integers. Integers are considered as atomic values. But set of integers is not containing atomic value. Suppose I am writing here, rather than 1, 2, 3, I am writing set 1, 2, 3. This is not atomic. This can be further divided in 1, 2 and 3. This you need to take care, right? Now second is what? Now suppose employee ID I am taking CS001, means CS is computer science department, and this is what ID of employee. So this is what? Non-atomic. This is not atomic, right? Because this can be further divided into CS and 001. Fine. So, and when obviously when an employee will left one department and shift to another department, then you have to change this ID, right? It cannot be CS. If he has moved from CS to EE, electrical department, so it should be EE, or you can say 001, right? So if you take employee ID as a primary key, in that situation you will get some problem, right? So now here, to get the information about the department of the employee, right, you know that the first two are the department, so you have to write down some coding, and after that you will have to interpret this identifier like CS and 001, and after that you will get what the department is, computer science, right? So but that encoding would be in the application programs only, not in database. Not in database we are storing it like CS and 001. In database we are storing employee ID as complete this one, right? So this would be a problem. This would be non-atomic as far as we humans are using the system, right? But database applications still treat it as you can say as atomic values, as long as it does not split this identifier. Fine, as long as it doesn't require to split this identifier, then in that case it will consider it as a atomic value, because maybe in this relation another attribute is there, that is of department. So using that attribute, that database application can get the information that which is the department of this employee, rather than interpreting this identifier, right? So in that case still the university schema would be in our first normal form. So these points are those students who are very curious, right? These are extra points, not the basic whatever in the first normal form, right? Now I hope I was able to clear your doubts if you have these kind of doubts. So this is all about first normal form. In the next video we will discuss what is second normal form, and if a given relation is given, then how to identify that that particular relation is in second normal form or not, right? So basically after that, after this video, in the next video we will need all these functional dependencies concept and that keys concept, right? So you must revise that concept first of all. So now I'll see you in the next video. Till then, bye bye, take care.